Perfect. So my presentation title is What is Under the Topsoil? And I wanted to talk about this because as soil scientists, I have the chance to see other things when we're out there digging a pit. We get to see things that most of the people don't see. I get comments from a lot of people that they just know what is the topsoil because that's what most people play with when they're gardening or when they're, I don't know, playing with the kids in the yard. When you're doing something soil related, most of the time you just get to see the topsoil. But I wanted to show you guys what a wonderful world is down there. So let's start. I'm gonna show you a couple things, but I need you to follow the basics with me. I don't know how much you know about soil, so I'm gonna start with the very basics. So what is the soil made of? The soil is a natural body comprised of solids, liquid, and gases, and is about 45% mineral composition, including the rocks fragments in there, a 5% organic matter, and a balance between air and water that comprise about 50%. So if you have more water occupying that airspace, you're gonna have less air. And if you have less water, like in the dry periods, you're gonna have more air. Those are always in balance. And right there, I added a couple pictures of soils. That this is what we call a soil profile. And as you can see, they're so different that you get to see colors and layers and structures. And that is what we're gonna talk about in the next hour. All right. So how is the soil formation? Why does the soil take so long to form? It is a very long process, and scientists said that 1 inch of soil, just 1 inch of soil, takes over 100 years to form, and I'm going to tell you why. The soil is formed by the interaction of parent material, topography, climate, and organisms through time. And it is also the result of 4 major processes that we call additions, losses, translocations, and transformations. But what are those and how they work together to form the soil? Well, additions refers to materials being deposited on the soil, like the leaf litter or the dust from the environment. It could be organic matter from plants or materials moving with the rising groundwater coming from below. What are losses? Well, everybody knows about erosion. That is a loss. And it is also like the water evaporation process. That is another loss. Or it could be nutrients taken by plants. Translocations. Translocation means the movement of material from one location to another, but not removing it from the soil. A good example is when you're tilling your farm. When we do tilling, we're removing soil from one spot, placing it in another spot, but it's still there, still in your farm, still in the land. So that is a good example. Another could be the movement of salts or gypsum or carbonates in drier environments. Or organic matter that moves downward in the soil. And we're gonna see that later. Transformations, those are a little bit tricky, but those are represented with something that everybody is familiar with, litter and organic matter. So you have the litter being deposited on top of your soil, and over time is going to be transformed into humus, that organic matter. Or it could be the minerals in the rocks. You know, you start with your rock, and over time, those are going to be transformed into clays. So now I want you to look at that diagram with me. I'll show you how the soil begins. So you have your rock. Over time, the rock is going to be fractured, and the action of rain and climate is going to be breaking down that rock into tiny little pieces or smaller fragments that is going to be releasing minerals. And then you have the plants showing up, playing it there. And over time, you're gonna have some horizons being formed. It takes a lot of time, but you're gonna end up having a well-developed soil profile like the last picture. Right, you have any questions with this? All right. So let's start with the fun part. What is under the topsoil? Under the topsoil, we have a lot of stuff. If you ask me, the first thing as a soil scientist that I think about is layers. We do have a lot of layers. We have horizons. So horizons are the result of those interactions between organic matter, parent material, and the different processes. And we do have what we call topsoil, which is comprised basically by the A horizon. But underneath, we have the subsoil and then the parent rock. So we call those major horizons O, A, E, B, C, and R. So let's talk about those horizons and what they mean. The O horizon is the loose and partially decayed organic matter. And in the A horizon, you have mineral matter mixed with some of that humus from the top. E horizon, pay attention, this is not always present in the soil. But when it is, my friends, you will see it. It's very obvious. You're going to see that later. So the E horizon is the zone of alluviation. You're going to have the clay and iron and aluminum oxides from that horizon moving downward and being accumulated in the B horizon. So the B is the zone of accumulation. And underneath, you have the C horizon, which is basically the partially altered parent material, and you end up with the bedrock or the R horizon. That is the parent material, the unweathered parent material. And that could be any kind of rock. It could be an igneous rock, a metamorphic rock, a granite. It could be any kind of rock, okay? So now that we know some basics about soils and how they're formed, I want to share with you guys some important information and something that's very cool. So soil is one of the largest reserves of carbon on Earth. The major one is on the rocks, then is the oceans, and then is the soil. Soil plays a major role in the climate change because it sequesters carbon, and you can see it. Also, the soils is very important because the diversity of organisms that live there. Scientists said that in 1 tablespoon of soil, you can have more than 7 million organisms. And if you think about that, that is around the same number as the people in the planet, and that is a lot of organisms. And there could be bacteria, algae, microscopic insects, earthworms, beetles, ants, mites, fungi, and much more. But only 1% of those microorganisms found in soil have been identified. And that means that we still have a lot of work to do. So when we talk about soils, we know like a large percent of the earth is covenant land. We do have a lot of soils. So we need to have a classification system in order to work with them and work with the land management. Most countries have their own, like Russia, Brazil, Australia. There's a World Reference Base, which is a part of the FAO, but United States have their own. And all the territories like Puerto Rico and Virgin Islands, they do follow the same taxonomy system. So in the soil taxonomy system, we have 12 soil orders. And the order is the broadest classification. We do have other classifications in the system, but I'm just going to focus on the soil series because it's the smallest classification unit. It's like the different soil types, and we have identified more than 20,000 soil series in the United States. That is a lot of diversity. So from the 12 soil orders that we have identified in the United States, the most common or the most extensive is the molly soils, and we call those the pretty soils. They covered around 21.5% of the country landmass. I want you guys to look at that map. The green shaded areas is showing you where those molly soils are. I saw a couple of them in Texas when I was working there. I was working in Central Texas. And I want you guys to take a minute and think with me. Look at that picture. How dark is that soil? That is a molly soil from Idaho. And if you think in the past, like thousands of million years ago, how big the old prairies would have been just by looking at the extension of that map. these deep, dark soils form because you have a lot of grass putting down deep roots in there. And that area was getting really cold, and the foliage and the roots, they were dying. So over time, those cycles were forming that soil with very rich organic matter. And that's what is giving the soil the very dark color that people normally associate with fertility. So we know that when you see dark soil, it means it's fertile, it's good for planting. And you want to have that in your land if you're a rancher or you're a farmer, right? Even for gardening, it's good for your plants. All right. So we already discussed that we do have a lot of organisms in there, and they interact with mammals and birds and all kinds of animals in there. It is a big ecosystem. But as part of that ecosystem, the soil is being disturbed. There is something that we call bioturbation, and that is basically the reworking of soils by animals or plants, especially by roots. And it's when they're burrowing or when they're ingesting and defecating the sediment grains, like the earthworms do. But I want you to take a close look at that picture I have right there. That is a ceiba tree from Puerto Rico. I know that tree is also in other parts of Central America and South America. Look at the root system. It is very impressive. Now think about the bioturbation that root system is doing in the soil. It is a big deal. So in soil science, there is something that we call crotobeans. I've seen those before. Those are pretty nice. And those are basically animal burrows, you know, those tunnels that they make when they're looking for shelter or when they're looking for food. So those animal burrows get filled with soil material that they're falling from the horizons on top of it. And those two pictures on the right, I took them when I was working in Connecticut last year. That was the first time I saw something like that. I was very impressed. I have to tell you, I was very impressed. My supervisor told me, you have to go to that land. That farms needs to be remapped. So get your tools, go there and start digging. And I found out, and I was like, whoa, what is this? Something happened here. I mean, look at the size of that crotobenia. It starts in the AP horizon and it's crossing down 2 horizons down there. That thing was huge. So you know the animal that did that was pretty big. That is very impressive. Also, under the topsoil, we do have a structure, soil structure. And the structure, I like it, it's pretty cool. Most people are gonna be familiar with granular structure, even when they don't know what they're looking at. Because when you're working in your garden and you're pulling those weeds or grasses that are growing in your garden, and if you bring out the root system, sometimes you're gonna see the soil attached to the roots. And if it's really good soil, the structure is gonna be granular. So sometimes you see it, but you don't know what you're seeing. Those aggregates are gonna be having different shapes. They could be blocky, they could be platy, they could be prismatic, that's the picture on the right. That prismatic structure, to me, that is beautiful, that is amazing. You don't get to see something like that very often, even when you're a soil scientist and that is your job. You don't get to see that very often. So let's talk about what we have under the topsoil. I already mentioned we have organisms, we have crotominians, we have horizons, we have a structure. But what else do we have out there? Colors, different colors, and this is one of my favorite parts. For us all scientists, colors are very important because they telling you what's going on in there without you having to run chemical tests to more information. If you think that soil is just brown or dark or blackish color, you're totally wrong, because soil could be from red to white, yellowish, bluish, greenish. It can have a lot of colors. We use the Monster Color Chart to describe our colors. And we have a lot of pages in there. So I'm telling you, we do have a lot of colors. So let's talk about that a little bit. Colors come mostly from organic matter and iron. So organic matter, because it has a complex composition of acids and other components, they're gonna give a dark color to the soil. So that's why we know when your soil is very dark, like brownish or black, you have a black color defined on the color chart, your soil is very fertile because it's gonna have a lot of organic matter in there. So the reddish color, orange, yellowish, brownish colors, those are coming from iron oxides. Iron oxides are minerals that are present in the rocks, and they're going to be present in the soils as well. So colors tell you a story. Why am I telling you this? Because you can tell how the water has been moving in the soil just by looking at the colors. For example, an even single color indicates that the soil is well drained. And when I'm saying well drained, I mean by that when it rains, the water is not going to be, it's not going to stay there. It's not going to be ponding in there for too long. The water just drains really fast. But if you have rusty spots and gray patches, like greenish or bluish colors, mostly grayish color, that is telling you poor drainage. That is telling you that the water table is really high right there, that those are soils that aren't going to be covered in water for very long periods. Sometimes it's a whole season. And when you have, I told you before that we need a balancing soil between air and water. So if that airspace is being filled with water and is covered in water for a very long time, you're going to have a lack of oxygen. And that is going to affect the soil dynamics. And over time, you're going to have a reaction in soils. So you're going to have iron oxides moving, leaving some areas, being transported by water, and being deposited in other areas. So that is giving you gray, green, and blue colors, but it's also giving you rusty spots. In the rusty spots is where you have that iron being accumulated. Look at those photos. The right photo, the photo on the right is from Alaska. That is what we call a hydric soil. Did you ever imagine when you're going out there to have fun or whatever you're doing in the land, that under the topsoil, the very dark topsoil that you're seeing, you have other colors, that the whole soil is gonna be gray? You don't even think about that. How amazing is this? Look at that bluish color, greenish colors. Those are telling you something, that you have poor drainage, that those areas are covered in water for a very long time. So what else we have under the topsoil other than colors? Oh, I'm sorry, we're still having more colors. So here we do have examples of redoxymorphic colors in a profile when the water table is high. So if you look at that profile, look at that soil profile in the right, those colors are more brownish. But then under 40 centimeters, you have a gray spot. But that gray spot is not uniform. It's not covering the whole layer. That is telling you something about the water dynamics that are happening there. In the photo of the left, you can see great patches under 20 centimeters, but like under 60, what's going on? The whole thing is gray. So it means that that area is covered in water for a very long time. So we do have a lot of colors under topsoil. Now let's talk about some green. And green, to me, is kind of cool. And I was very impressed when I was doing this. I'm gonna tell you something, guys. I've never seen green soils before. When I was doing this presentation, I was very surprised when soil scientists told me, hey, we have some green soils in New Jersey. Those are made of glauconite. Glauconite is a mineral that is formed under marine conditions, water marine conditions. There is a picture there, so you can see an example of that mineral. In New Jersey, those soils were formed on rocks that were underwater 100 million years ago. So when you look at that soil and you look at that color, you need to think, what's going on here? Because we know green soils are not common. That is not something you get to see every day. that is when you have to think about the geology. You need to think what happened here? Why is this environment so different? So we need to think about geology for a moment. The whole thing was formed underwater, and it was exposed a million years ago. It was exposed, and now that the water is down and the ground has been uplifted, it's weathering. And in the weathering process, the soil is still keeping some of the properties of the prime materials. That's why the soil is green. We have 325,000 acres of those soils in New Jersey. They're also registered in other parts of the world, like Poland. In Poland, they're younger. The rocks containing the glauconite, they're 20 to 30 million years old. I know it's still a lot of time, but they're younger. So now, I want you guys to tell me, and I really want somebody to talk to me right now and tell me, what do you see in that picture? What is being pointed by the yellow arrow?
So I invite anyone to answer or put in the chat. I see someone put in the chat hydric soil.
I can see the chat right now.
So I can read. I'm gonna read from the chat, and what I see is someone who put in an answer. They think it is hydric soil. What the arrow is pointing at.
No, it's not a hydric soil. What I'm pointing is the lighted color layer. You see dark on the very top, and right under the topsoil, there's a lighter layer. And right underneath,
you mean sandy?
It is sandy, but that is the E horizon. Do you remember when I told you at the very beginning, E horizon is not always present, but when it is, you will get to see it because it's very obvious. It's so light. Okay, so the photo on the left, I took that photo when I was working in the White Mountain National Forest in New Hampshire this summer. That was like 2 or 3 months ago. I never seen something like that before. That is the kind of soil profile you get to see in books. You get to see that in college all the time in books. But when you're working in there, if you're not working in the forest, you're not gonna see something so pretty like that. It's a well-developed soil where you have the topsoil followed by the E horizon. Right underneath what you have, a darkest layer, that is some organic matter that have been moving downward in the soil profile. But you also have the accumulation zone. You see those orange, reddish colors under the E? That is the accumulation zone. So all those materials moving from the E have been accumulated there. And that kind of soil is a spotosoil. A spotosoil is one of the 12 soil orders that I mentioned at the beginning. And those soils are going to be found in regions with cold climate and coniferous forest, in places with abundant rain and good drainage. Some of the properties of the soils is that they're rich in organic matter, like I said, they're happening in forests. They're rich in oxides, but they're acid. They're very acid soils. And the problem with that is affecting the fertility. So spotted soils are not good for farming. They're good for the forest. You're gonna have forest there. You're gonna have a lot of trees, not just conifers, but you're gonna have oaks and maples and American beech and all kind of trees in the forest. You've seen the forest before, I'm really sure of that. The photo on the right is from the Adirondack Mountains in New York. And you can see the E horizon there, but it's more grayish. So it's not always gonna be white. We just call it light color, but it's not always gonna be white. So now I'm gonna tell you a pretty cool story. I've been working in New Hampshire during the summer because there are still a few parts from the United States that hasn't been mapped before, like Alaska, Wyoming, and the White Mountains in New Hampshire. So we're doing initial mapping. They give you a GPS, they give you equipment, and you have to go there, you have to hike. Sometimes you have to be hiking for 2 or 3 hours before you get into your set of coordinates where you're gonna start digging. So I've been working in the forest, walking there, thinking about the landscape, being aware of wildlife activity, because let me tell you something, friends. We do have bears and we have moose here. I've seen 2 moose in the summer. Those are mean. So you have to be careful when you're working out there. You have to pay attention to your environment, but you still have to go and do your job. So I start digging. When I find my spot, I start digging, and then I found something really, really, really cool. And what I'm gonna show you guys, nobody has seen it before, just my supervisor and the people that works in my office. Look at this. Isn't it that amazing? Double spottosaurs here. This is not something very common. You don't get to see something like this very often. Actually, we asked to the soil scientist that has been working for 20 to 30 years in the Northeast, especially in that forest, and they said that they have never seen something like that before. So last year, my coworker found the first pit, is the photo in the center. And they were really surprised by that because you can see the double sequence of layers of O horizon, E horizon, followed by the B with those orange colors. And you wonder, what's going on here? This is not very common. Maybe it's an anomaly. It doesn't happen in other areas of the landscape. But guess what? This summer, I found 2 in different areas of the forest because, like I said, it's a big forest. So we get to work in different mountains and different areas of the forest. I found 2 double spottosaurs. So this is what we call the bony soil because you're not gonna see this very often. So you ask yourself, what is under the topsoil the whole time when you're walking down there? Because you never find where you never know where you're gonna find down there. So does anybody have an idea of how this could be formed? How something like this happened there? Any ideas? No? Okay, I'm gonna help you.
I was gonna guess. Is it because of the glaciation?
Could be. We don't really know, but we do have a theory. You remember, guys, when I told you that the O horizon isn't the surface, right? It's the top. It could be O or it could be A because O is not always present. If it's been plowed, like in a farm, you're not gonna see it. But it's always close to the surface. The thing is, if you have an O horizon down there with an E horizon followed by a B, that's telling you that was the surface at some point. That was the surface. And something happened that it was covered with new materials. It was covered by a thin layer or a thick layer of material. And the whole process started over. And now you have an O horizon being developed right on top of the sequence, followed by an E and another B, and then down there is the original sequence. So I can tell you a story just by looking at that. But that is our guess. We don't really know when that happened, how long it took to form. We don't really know. Like I said, nobody has seen this before. This is not documented in the academy. No, in the academia, nobody knows. So this is the first time we find something like this. We have seen 3 profiles like this before. So I think this is pretty cool. And you guys are pretty lucky by seeing this with me. And now we move from the forest to the prairies. So do you guys remember what is the prairie soil? What is the soil order that I mentioned in the beginning? Let's start with M. No?
Is it the mollisols?
Yay! Mollisols. So mollisols or prairie soils, I mentioned they're very fertile, they're very dark, they're rich in organic matter, but they also could be shallow soils. And when I say shallow soils, I mean by that there is a root limiting layer pretty close to the surface. So the plants are not going to be able to grow not very well because they're going to be limited in resources in there. So when something like that happened, at least in the prairies, we have petrocalcic horizons. This is related to geology because the carbonate is coming from, the parent material is coming from limestone or rocks rich in calcium carbonate. That carbonate is going to be moving in dry areas. That carbonate is going to be moving with the water. It's going to be being deposited and form a very hard layer. And that hard layer that is there is going to limit the forming activities. So the calcium carbonate accumulation, we call it petrocalcic horizon. Those are very hard, so it's going to be really hard to work in there. For us to break it down, we really have to put a lot of strength with the shovel, and it's going to damage your shoulder and your arms. I've been doing that before. So really, in the Euphrates, not all the soil is perfect. So something like this, you can use it for rangeland or for wildlife habitat. So what do we have under the topsoil? We can have root limiting layers very close to the surface like this. So those photos are from Texas. I took the photo on the right, Knoxville series. That was the first one that I saw of petrocalcic horizon. It might not be very impressive for you, but it was for me because where I'm coming from, from Puerto Rico, the soils are dark or reddish, but I've never seen white before. And when I saw white in there, it blows my mind. It was really amazing. So here we have our geologic horizons. Those are very common in tropical regions, like I mentioned, Puerto Rico. Those are layers where the clays are going to be accumulating and iron oxides. And I mentioned before that iron oxides give the soil a reddish color or orange or yellowish. So here is a good example. Those are made of red clays. Actually, the photo in the center, the Spire series from Texas, I took that photo. There you have a topsoil followed by a argillic horizon where all the clays are going to be accumulating. And right underneath, you have petrocalcic horizons and calcium carbonate rocks, limestone. That's what we call limestone. And it's very impressive seeing that. I mean, the mosaic of colors is pretty cool. So what I'm going to show you next is awesome. I get very excited with this. I've never seen this before in my life. A colleague sent me those pictures, and I want to share it with you guys. What's under the topsoil in the tundra? Ice. Like I said, I've never seen this before, like in real time. But to me, this is amazing. I mean, look at that ice layer. It's very thick. So this is a jelly soil. Jelly soils are another soil order, one of the 12 soil orders. And those are soils containing permafrost within 2 meters of the surface. And if you guys don't know what is permafrost, permafrost is the ground that remains it remains frozen at least 2 years. So where did this happen? In very cold climate like Alaska, Canada, Siberia, Northern Scandinavia, Greenland, Antarctica, you know, all the very cold places on Earth. Those are gonna be the only places having this. This is not something that you're gonna find in the United States, you know, in mainland, just like that. I think this is pretty cool because when we go out there and we're hanging out there, you know, having fun in the landscape, we don't think that we can find soil in there. I know some people, maybe they have been in contact with that, but it's not something very common. So in there, in those very cold places where we have the ice, we're gonna have some structures. So there is something we call ice wedge, and an ice wedge is a crack that's been filled with ice and cryoturbation. Cryoturbation is the photo on the right, and that is the mixing of soil materials from various horizons due to the freezing and thawing cycles. So you guys are aware that places like Canada and Alaska, they're very cold, but there's some periods during the year that the ice melts So that thawing and freezing process is affecting the soil and is creating all these structures. So that is also under the topsoil. I'm gonna show you guys something else. In this photo, you get to see ice lenses. Take a close look at that. How is the topsoil in the photo of the right? It's dark. It looks like a normal soil, but you have ice down there. You still have ice. It's not very thick, like the first picture from Alaska that I showed you, but it's still there. So I can see how under the topsoil you have ice structures that are going to be affecting farming. That is why in those places you can do farming activities all over the year. You only do it by season. And on the photo of the left, you have more ice lenses. They're very thin, but look, just one clod of soil, how many ice lenses have in there? Now we go to the city. So have you guys seen any construction site in the city or close to the city that when they're bringing the backhoes and they're starting the digging for the foundation, sometimes they're uncover soil profile? I don't know for you guys, but for me, it's pretty cool. If I have the chance to stop by and take a look, I'll do it. Because you get to see pretty cool stuff. And sometimes when you're digging with a backhoe, they go really deep, especially when they're building the foundation of something there. So here is what we call urban soils. Urban soils are different. Those are going to be affected by human activity, and that's why I bring the sample of construction. Because when we're building something, we remove the topsoil, we remove some of the soil layers in order to do whatever needs to be done, and then we bring something else to put it back in place. So that is what we call in human altered and human transported materials. That example is from Detroit, Michigan. And the soil profile is actually the spot that the guy is digging in the photo of the left. And you get to see the natural soil as on the very bottom of the picture, the lighter color. And you see the transition of different colors from the bottom to the top. Those are transported materials. And those in particular, they have been deposited there, and they can contain a mix of artifacts, rocks, sediment, debris. And this is going to be the new parent material for the urban soil that is going to be developing there over the next years. Now look at this. What is under the topsoil in the city? Artifacts. Because like I said, if you're building something and you're removing the natural soil, you're disturbing the soil, you get rid of it, and then you have to bring it back, cover it back in order to finish your project and say it's done. Sometimes humans bring a lot of stuff to fill that land. They put bricks, concrete, wires, steel, asphalt. They put a lot of things in there. Those things are going to be part of the new soil profile. So when you're walking in the city, what do you have under the topsoil? You have artifacts. The photo on the right is the Lady Liberty series in New Jersey. That one is different because in that one, you have human transported materials containing oysters. That one in particular, you have a transported topsoil. You can see the dark layer. Is coal slag with artifacts, and it's over a spoil deposit. The spoil deposit is where the oysters are, the yellowish color, over the gray natural soil. Look what they have created. Look at those colors. This is what we're doing to the soils in the city. So the precious spoil refers to the unconsolidated mixed sediments composed of rocks, soil, or shells that are being extracted during dredging and dumping activities, when we're working on marshes or coastal zones, those materials being removed from there are going to be deposited somewhere else. Here is a good example. That's why you have oysters in the city. But what else is under the topsoil? Bedrock. And I said before that the bedrock could be any kind of rock. It could be igneous, sedimentary, metamorphic. And what is important about this is the bedrock becomes the parent material of the soil over time. Here, I wanted to bring a couple examples of that, because I mentioned we have over 20,000 soil series or soil types in the United States, and they're all coming from different rocks. Here, Quincy series on the left is a soil made of Ionian sand. Look how different it looks like compared with the Gem series, which is made of basalt, or the Ola series made of gneiss. Gneiss is a metamorphic rock. Look how different they look. Take a close look at the Bayamon series. Bayamon series is in the tropical areas, is in Puerto Rico. That soil, I got to see it in person. It was very red. In the picture, it looks more orange, but it was very red. And that is made of sedimentary marine materials. And right on the next picture, we have the Pywell series, which is made of organic materials. And the last one is Harper series, and I took that picture in Texas. That soil, the primary material is limestone. So right here, we have a good example of how different primary materials are being creating soils. Igneous rocks, metamorphic rocks, and sedimentary rocks. So what is under the topsoil? You guys see, we have a lot of stuff down there. It's not just, the soil for gardening. It's something else. So bedrock is also important because you have the same rocks that can create or can evolve into different soils. For example, here I have 5 soil series or 5 soil types in the United States made of basaltic rock. Basalt is an igneous rock, and you can see how in Idaho, the soils made of that rock are dark. Yes, there could be other things happening in that environment that are giving him the soils the properties that they have right now. But look how they look. They could be similar in terms of the colors because they're dark. But I want you to take a look at the empty soil, the flybout series. It's the second picture from the left. Empty soils is a soil order, is the younger soil. It doesn't have a lot of development. Look how the rock is being breaking down in smaller fragments. You can see the fractures, you can see the cracks in the rock. But take a look at the molly soil and the vertisol in the left and the right. There are more developed soils, and you can see the rocks at the bottom. It's still basalt, but what happened in Puerto Rico, in tropical areas where you have a hot and humid climate? The soil is different. You have different colors. You have different minerals, whether in there, they're all coming from the rock, but look what they produce, different soils. That's how we have different soil series in the United States. And they're coming from the same rock. In this case, they're all coming from the same rock. I think, guys, this is pretty cool. I don't know what you think about that, but to me, this is amazing. But there is something else. There is a soil mystery, something like this. And I'm really sure nobody here has seen something like this before, because this is not something common in soils. Actually, that spot is my graduate research spot when I was in college. That is my thesis, right there. Can you see horizons there? Like the horizons I showed you in the previous soil profiles, like that diagram, the block diagram with the O, A, E. Can you see that here? You're not gonna see it because the horizonation here is very unusual. And what happened here is that the parent material was playing a major role on it. I want you guys to look at me at the camera. I'm gonna show you something here. So what happened in that soil is that the parent material is a stratified sedimentary rock. So you have something like this. The papers are acting like different layers. And in Puerto Rico, tectonics are a big deal. So you have a lot of tectonic activity there affecting the rocks. So in a major tectonic event that happened a million years ago, the layers of rock that were like this, one on top of the other, they were compressed and they end up with a shape like this. Now your layers are in vertical position. And that is gonna give the appearance of columns in the soil profile. This is a soil mystery. It was very hard to explain what happened here. Soil scientists in Puerto Rico, they were getting crazy with this, bringing all kind of explanations that were all wrong. Because what was important here was the parent material. Take a look at the rock, take a look at the geology around. So the topsoil here, you see in the picture, is very thin. It's where the grass is growing. It was disturbed in the picture because of backhoe when we were digging here. But that soil had a very thin topsoil. It was extremely acid. The whole profile was extremely acid with the pH in the scale from 3 to 4.0. This is not good for farming. And I remember this is on a big farm in the west coast of Puerto Rico. And when I was talking to the farmer, he told me that he needed to apply some fertilizer and liming products in order to make the soil better for the plants, because it was very acid. And he never knew what was going on there until I started digging and I found this. And then I can tell you a story about it. Isn't this amazing? To me, this is wonderful. This is something you're not gonna see before. This is not something that many people is aware of it. It hasn't been described before. I've never seen it in any other place. I mean, this was my research project. So when you go out there, next time, when you're walking in the landscape, think about what's under the topsoil. There's so many things down there that takes a very long time to form. I wanna show you guys something else. And this is something else that I'm really sure a lot of people, they're not aware of. Subaqueous soils. Subaqueous soils are soils that form under a continuous water column. They could be formed in freshwater and marine environments like ponds or estuaries and tidal embayments or lakes. Those sediments in shallow waters, they meet the definition of soils because they support rooted plants. In these cases, it's mostly eelgrass, but if eelgrass is growing there, then you can call it soil. Yes, it is underwater. It's very unusual, but it's soil, and we're working with it. Right now, we are mapping, and when I say we as an agency, NRCS, we're mapping coastal zones all over the United States and Puerto Rico, and it's a project ongoing. Here you have an example of some of the cores that we extracted from Massachusetts and Connecticut last year. Take a look at the core. It's gray, but you can also see the layers. You can see some yellowish colors, some reddish colors, so you can tell those are different layers. But take a look at this one. This is from Martha's Vineyard in Massachusetts. Actually, the photo in the left is telling you where the core was extracted. You can see it was very close to the land. So in that core in particular, we have a buried organic horizon. What is telling you? It's telling you that the surface was there at some point, and something happened that was covered by more sediment. So it could be the sea level that is rising. We know sea level has been rising for a very long time. And when the sea level rise, it's bringing more sediment with it. So now the organic horizon that was the surface before is being covered by more material. So this is an example of what we see under the water in the coast, subaqueous soils. So now I want to finish my presentation showing you a couple more things, like for example, what we can do with our knowledge of soils. And to me, this is very important. This is part of my job. And most people are not aware that what we do is public information. We do soil maps. And those soil maps are very useful to identify soils of an area, soil properties, the suitabilities and limitations for land use, like for example, how you can use it for crops, for parks and lands, playgrounds, ponds, dwellings, roads, streets, and all kind of stuff. There is an example of a small soil map that I made last year in Connecticut. That was my first project in Connecticut. It's a small farm. It's an agricultural center. It's mostly for teaching, but they wanted to know the soils in the property because they want to plant some stuff. And they want to know how good is the soil for that. And other things that we can do with soils information is we can create ecological sites. Those are land type classification systems that describes ecological potential and ecosystem dynamics of land areas. The landscape division is defined by the combination of soil type, landform, geology, climate, and biotic factors that could be the different plant species or the plant community composition, the animal biomass production, and the wildlife vegetation interaction. There is an example of different ecological sites. You have 4 down there: the low tidal marsh, the subaqueous flat, high tidal marsh, and the deep rocky till. So this is something else that we can do with source information. And I want you guys to think about what are the soil's functions. What do we get? What products do we get from soils? What services do we get from soils? Because most people think it's just farming, that we just get food from them, that we just get food to feed the animals that we eat later. And it's more than that. We get oxygen supply from the soils because we need the trees planted in the soil to give us oxygen, right? The soils provide clean water. They're really good filtering water and pollutants. They provide shelter. How they provide shelter? Well, they are growing big trees that we use for lumber, for building our houses, but they're also providing the land, you know, to where we build our house. So it provides shelter. Clothes, where are the clothes coming from? Mostly from cotton. Where is the cotton coming from? From the plants, from the soil. Soils also help with carbon sequestration, and there are many other soil functions. So keep this in mind. Soil is very, very important. And to me, life starts with soils. So keep that in mind. Because, especially because of this, only 3% of the world's soils are suitable for agriculture. That is very sad. Like 75% of the planet is covered in water. And from the rest, we have like 13% is covered in rocky mountains and deserts and swamps and ice, so we can really do much in there. We also have more rocky areas or areas that are too hot or too wet. They're very infertile, so they're not good for farming. So really, what we only have is 3% of arable land that is going to be affected by other factors. So we really need to take good care of the land. That land is going to be affected by slope, erosion, acidity, low fertility, climate change, salinity, drainage aspect. There's so many factors that affect the land. So we really need to be good and use the land, but taking care of it so we would have it for future generations. This is part of what we do in the Natural Resources Conservation Service. So I wanted to share that with you guys. In case you want to know more information, I said that the maps that we do, they're public record, they're public information. So my agency, the NRCS, is the lead federal agency in charge of the inventory and mapping and interpretation of soil resources in the United States and territories. We created this web soil survey. This is where we share the soil's information. If you go to that website, I can post it later in the chat if you want, and you hit that green button, it's gonna take you to this app. So there you just need the coordinates or the address or the state and county, the area that you wanna know information about soils. You put it in there, and then you use that red a square to delimit the area of interest. And once you do that, you're gonna have a blue square showing you your selected area. Then the tabs on the top are gonna turn on, the soil map and the soil data explorer. And there you're gonna have a lot of information about the different soil types in that area. And this is gonna help you determine whatever you need to determine for the land. Whatever you wanna do that you need to know soils information is gonna be there. And this works in a major scale. So if you're working in a very tiny, small farm, you're gonna have general information. If you need something more specific, you're gonna have to call a soil scientist to do a soil test there. This is the last example I wanna show you guys. With soil survey, you can use the resources there to build your own maps with information. This is a drainage class map that I made. I think this is in Connecticut. I wanted to show you guys the scale, how it works, different colors. So here, you can tell where are the good drainage areas and where the poor drainage areas. This is important because in the poor drainage soils, you're gonna have wetlands. What do we have with wetlands? A lot of birds, right? And if you're a fan of birds and you're looking for birds, this is the places that you need to go. But think about something else. If you wanna buy land, if you wanna build your house or you wanna develop something on land, you need to know where the flooded areas are gonna be because you don't wanna build something close to those areas. This is something very useful. This tool, you can use it for other things. Like we said, we have a lot of stuff in there. And this is public information. It is in web soil survey. If you don't know how to use it, if you need any help, you have any questions, you can always contact a soil scientist from NRCS. We are we're nationwide. In every state, you're gonna have a soil scientist, so you just have to contact the right person for help. We're happy to help. So I wanna close. I wanna finish this presentation telling you guys, sharing with you guys this quote from Franklin Roosevelt. He said once, a nation that destroys its soils destroys itself. And I think that is true. Because like I said, to me, life starts with soils. There's so many services that we get out of soils. We really need to protect our soils for future generations. We know this is happening. And that picture is from the Dust Bowl. I don't know if you guys are aware of this. I know this is something you learn in high school. The Dust Bowl was in the 1930s. It was a major event. A lot of land was damaged by it. So this is a good example why we need to take care of our soils to prevent this kind of erosion.
All right. Thank you for such a wonderful, fascinating, and very exciting presentation. I do want to remind everyone, I did see some people coming in closer to 7 that this was started at 6 and it was recorded. So even if you came in late, the link will be shared with you and you'll be able to enjoy this presentation again. So I do actually have a quick question. I love the excitement throughout the presentation. I just am dying to know how you got yourself interested in the soil.
You want to know why? I'm a geologist.
Oh, really?
Yes, I'm a geologist. When I started in college, I wanted to be a geologist, and then you have to do research before graduating. Your last class before graduating is a research project. So I was working with cores that they were drilling in Puerto Rico looking for groundwater. They didn't find the groundwater, so they put those cores in military bunkers, and they were abandoned there like for 20 years or so. So my advisor told me about that. And when I started to work with that, I needed to describe the whole rock sequence. I was trying to recreate the environment a million years ago, where those cores were extracted. It was a valley, it's a major agricultural valley in Puerto Rico. And to me, it was kind of weird every time I found a soil sequence in that core that was around 100 feet deep. It was pretty deep. He said, "Oh yeah, that's just a paleosol. Keep describing the rock. We don't care about that." And I was like, "What? This is telling me this was the surface a million years ago, and you're telling me it's not important? That doesn't make any sense." So I enrolled myself in my first soils class. I wanted to learn more about soils because I knew they're important. Man, and I just fall in love with it. Soils are so wonderful. They're amazing. There's so many things about soils that you can learn. And I ended up doing a graduate degree on it. I have a master's degree in soil science. And I mean, you saw it. You saw my research spot. That soil was wonderful. It was amazing. So that's how I ended up being a soil scientist here.
That's definitely a really cool story. Before anybody ends up asking any other questions, which I will invite you to in a second, either through the chat or just speaking up, we do have some other exciting talks coming up. Right under your nose, a mini beast safari with Tanya Gale, finding solace at Theodore Roosevelt Island with the well-known Melanie Chokas Bradley, and monarch butterflies, mystical migrants with Mark Garland. So we hope to see you there. And at this point, it will answer any last-minute questions, and then we'll be done for the evening. All right. Let's see if I can get the chat. I will share. Someone else shared a quote from Patrick Henry saying, he said, "The greatest patriot is who stops the most gullies." I like that quote as well. But I don't see any other questions coming through. So I want to thank you again for such an amazing, wonderful presentation. I hope we all learned a lot of information about what's under the topsoil. I will stop my share so we can all wave and say goodbye for the evening. All right. Thanks again, everyone, for joining us tonight.
Thank you.
And we hope to see you at our future presentations.
Sure.
All right.
Thank you so much for the invitation.
Yes, thank you so much. Have a great evening, everyone. Bye-bye.
Bye.